Hi students, I'm Reema. Today I'm going to start the very first chapter of class 9 CBSE. The name of this chapter is Number System. First chapter of CBSE 9th Standard Maths. So in this video, I'll just give you a brief idea of what is the content of this chapter, excluding the exercise part. The exercise part I'll do first in another video. We are going to categorize the numbers. The first category is natural numbers. We denote it as N. And you all know that natural numbers are the numbers 1, 2, 3 and so on until the end. So the natural numbers are 1, 2, 3, 4 and so on, right? The next category is the whole numbers. You all know that when we add 0 to the natural numbers, we get the whole numbers. We denote whole numbers as W. So the whole numbers is 0, 1, 2, 3 and so on. And the next category is the integers. We denote integers as Z. And you all know that integers are a group of positive and negative numbers. So when we look onto the number line from 0 to the right and 0 to the left, all are integers. That is 0, 1, 2, 3, 4 and so on, and -1, -2, -3 and so on. So a group of positive numbers and negative numbers are integers. And the fourth category is the rational numbers. You all have studied, right? The rational numbers are numbers of the form P by Q, where P and Q are integers and Q not equal to 0. For example, we have 2 by 3 minus 5 by 6, 16 by 9. These all are rational numbers. See, they are of the form P by Q. P and Q are integers and Q not equal to 0. So, we have learned, till now we have learned 4 categories of numbers, right? Natural numbers, whole numbers, integers and rational numbers. There is one more category, that is irrational numbers. So what will be irrational numbers? Irrational numbers are numbers which are not of the form P by Q, where P and Q are integers and Q not equal to 0. For example, root 2, root 3, root 15, these all are irrational numbers. So, you know that in rational numbers, these all form natural numbers, integers, whole numbers, these all form into the rational number categories, right? Because the integers, whole numbers and natural numbers, we can all represent as P by Q form. For example, we take 2. 2 we can represent as 2 by 1, right? For example, 0. 0 we can represent as 0 by 1, right? For example, we'll take a negative integer, that is -5. -5 we can represent as -5 by 1. So, rational numbers means what? Rational number includes natural number, whole numbers, integers and also the fractions, right? So, now we know that real numbers are nothing but rational numbers plus irrational numbers. So, Another category, real numbers. This is the whole collection of numbers. Okay. So real numbers means what? Rational numbers plus irrational numbers. So now you have completed all the numbers in the number line, right? In the number line we have completed all the numbers. That is, we have the natural number, we have the whole number, we have the integers and also fractions, that is the rational numbers, and then we have the irrational numbers. So we have the whole set of numbers in the number line, and that is called real numbers. So the number line is actually called real number line. Okay. Also you have to understand that every real number is represented as a unique point in the number line. See, if we want to represent a root 2, somewhere it falls around, somewhere here, I think here it falls, right? So every real number can be, every real number means what? Rational number plus irrational number. So any number can be represented as a unique point in the number line. I have told you every real number is represented as a unique point in the number line, right? Now you know real number is rational plus irrational. Rational includes what? Natural number, whole number, integers and fractions. You know how to represent a natural number in number line. You know how to represent a whole number on a number line. You know how to represent integers on a number line. And also you have learned how to represent fractions, that is rational numbers, on a number line, right? Now in this topic we will learn how to locate rational numbers on a number line, irrational numbers on a number line. These are very important topic, so pay attention to this topic. Now for example, I will show you how to locate root 2 on a number line. For this, first you have to draw a right angled triangle. O, A, B, right angled at A. And now you know OB is a hypotenuse. So let's say OB is root 2. Now what is the Pythagoras theorem? By the Pythagoras theorem, you know OB square is equal to OA square plus AB square. So root 2 the whole square is OA square plus AB square. You know what is root 2 square? It is 2 is equal to OA square plus AB square. So how will we get which, by adding which two squares we'll get 2? You know that 1 square plus 1 square is 2, right? 1 square plus 1 square. So now OA is 1 and AB is 1. So OA is 1 and AB is 1. Now we got all the sides of this right angle triangle. So it's very easy to plot on a number line. So imagine this is a number line and you have, imagine this is the origin O, and you can take A point after 1 unit, and then at A you can draw a perpendicular line, and in the perpendicular line you can mark point B as 1 unit, and then join O and B to get the measurement of root 2. And then you can plot it on the number line. So I'll show you how to do that. We have OA is equal to 1. Now I'll draw a perpendicular bisector from the point A to get this line, AB line. You know how to draw that. First I'll draw an arc. Now from this point I'll take more than half of the radius . Now you can erase this part, okay? The arcs and all you can erase. You just need this perpendicular line. And now what we have? We need AB. AB, that is 1 unit. So from A, 1 unit, this is B. Now we know that OB is what? Root 2. This is 1. We'll join OB. Which is root 2. So I'll take that measurement. From O to B, I'll take and then plot this on the number line. So this point is what? Root 2. I'll mark it as P. So see, we have marked an irrational number root 2 on the number line. Now I'll show you how to plot root 3 on a number line. Root 3 is also an irrational number. So first we'll draw the number line. Before that, we have to draw the right angle triangle, right? So this is my right angle triangle OAB. Now this is root 3. So by Pythagoras theorem, what we have? OB square is equal to OA square plus AB square. Root 3 square is equal to OA square plus AB square. So 3 is equal to OA square plus AB square. Okay, so in order to get 3 as a sum, what must be OA and AB? So you know that 1 square plus root 2 square. 1 square plus root 2 square. How much it will be? 1 square is 1 and root 2 square is 2. So 1 plus 2 is 3. So now we know that OA is 1 and AB is root 2. So OA is 1 and AB is root 2. So now we'll plot this. So for that, first we'll draw a number line. mark origin O. Okay, and now we know OA is 1 unit. So I'll mark 1 unit there. So this is OA, right? So OA is 1 unit. Now we need to plot what? Root 2. So first we'll plot root 2. How will plot root 2? So now how will plot root 2? You know that if a right triangle is having OA and AB 1, then we'll get the hypotenuse as root 2. We have done it earlier, right? So here, now I'll use a protractor to mark my 90 degree. Okay, so from A, I will mark a 90 degree. Okay, this is my 90. So I'm having 1 here. And if I get 1 here, I know this is root 2. So with the help of compass, this is 1 unit. So I'm taking the 1 unit and mark it here. So this is 1. And I know this is what? This is root 2. Root 2 is what? O, distance between O and this, right? Root 2. So I'll mark that on my root 2 on my perpendicular line. So now I got what? The point B. And here is root 2. And now I join O and B. So this is root 3. Now I'll take that measurement from the origin till B, that is root 3, and plot it on the number line. So this is root 3 on the number line. So I'll brief it again. Location of irrational numbers on a number line. So we know now we are going to learn how to mark or how to locate root 2 and root 3 on a number line. For this, first what we'll do, we need to draw a right angle triangle. That is OAB perpendicular at A. So by the Pythagoras theorem, we'll find what? OB square is equal to hypotenuse square is equal to base square plus altitude square, right? So OB square is equal to OA plus AB square. So we'll get what? OA and AB as 1 and 1. OA is 1 and AB is 1. So now we'll plot this triangle on the number line. So that we'll get the hypotenuse, and once we get the hypotenuse, what? We can easily take the measurement using a compass and plot it on the number line. So what we'll do, we drew a number line and we mark the origin as O, and now we have OA as what? 1 unit. So I marked OA as 1 unit. And then what we need to do? We need a perpendicular line, either by using your protractor or by using the perpendicular bisector method by using a compass. You can draw a perpendicular line from A, right? I've drawn a perpendicular line on A, and then what we did, we know that AB is 1. So I marked AB point. I took this measurement OA and plotted the same here and got B. Now we know OA is 1 and AB is 1. So by joining OB we got what? Root 2. And take the same using what? Using a compass and plot it on the number line. So we got a point B on the number line, which is root 2. Similarly, for root 3 also what we did first? We plotted a right angle triangle, which is OAB right angled at A, and then the hypotenuse we marked it as root 3, and now by the Pythagoras theorem, you know OB square is equal to OA square plus AB square, and now we know OA is 1 and AB is root 2. So first on the number line mark the origin, and we know OA is what? 1. So OA we have taken as 1 unit, and we know that a line is perpendicular at A. We have drawn a perpendicular line by using a compass or a protractor, your choice. Perpendicular at A. Perpendicular at A, and then what we need to mark? We need to find root 2. You know, for finding root 2, the root 2 to be the hypotenuse, you know the base and the altitude must be 1 each. So first in this perpendicular line I marked what? 1 unit. 1 unit I marked here for getting what? For getting this is root 2, for getting the hypotenuse. And then I got root 2 and I marked the same, this measurement I have taken. This measurement, see, this measurement I have taken from A and marked the point B to find, so that AB is root 2. Now we got the point B. We got the point B and we know that OB now is root 3. So OB is root 3. Take the measurement and mark it on the number line. So the next topic we'll be discussing is the decimal expressions of real numbers. We all know that real numbers are categorized as rational numbers and irrational numbers. So first we'll study the decimal expressions of rational numbers. Okay, so to find the decimal expressions of rational number, we'll take a few examples. For example, we'll take 10 by 3 and 1 by 5. Okay, so to find the decimal expression of 10 by 3, what will we do? We'll do the long division of 10 divided by 3. So that 10 divided by 3. So 3 3s are 9. Remainder 1, then 3, again 3 3s are 9, remainder 1, 0, 3 3s are 9, remainder 1. So what can you see? It's not ending, right? The quotient is not ending. So the answer is what? The answer is 3.333 repeating. So if this is repeating, 3 is repeating, how will we represent that? We'll represent this as 3.333. 3 bar. Whichever term is repeating, we'll put a bar on that. Okay, here 3 is repeating, so we have put a bar on top of 3. So 3.3 bar is the answer of this. And now we'll see 1 divided by 5. 0.210 0. So here the answer is what? 0.2. So what have you? And the next one, I'll show you how to locate root 5, the irrational number root 5 on a number line. And for this, first what we do, we need to draw a right-angled triangle. What is that? O, A, B, right-angled at A. And now we know that the hypotenuse is root 5. So by the Pythagoras theorem, what we have? OB square is OA square plus AB square. So root 5 square is OA square plus AB square. So root 5 square is what? 5 is equal to OA square plus AB square. So in order to get the sum as 5, what should be OA square and OB square? You know that 4 plus 1 is what? 5. So 4 is what? 2 square. And 1 is 1 square. So OA we can take it OA square 2 is 2 square plus 1 square. 2 square is 4 plus 1, 5. So now we know that OA is 2 and AB is 1. So OA is 2 and AB is 1. So what we do? We'll plot this on the number line. We'll draw this triangle on the number line. So for this, this is my number line. I'll mark my origin O, and I know OA is 2 units here, right? OA is 2 units. So I'll mark 2 units. Okay, this is my 2 units. Okay, so this is my A. Okay, and this is 2. And what? Now I need to draw a perpendicular line AB. For that I am using now a protractor. Okay, so I'm having a perpendicular line, and now AB is 1. It's very easy, you know. Root 5. I marked my point B. Now AB is 1. Now if I join OB, what will I get? Yeah, root 5. So I am joining O and B. Now this is root 5. Now I'm taking the measurement with the help of my compass. So OB measurement I have taken. So this is root 5. So it's very easy, right? First, we have drawn a right angle triangle marked as OAB, right angled at A, and now we mark the hypotenuse OB as root 5, and by the Pythagoras theorem we found OA is 2 and AB is 1. We marked it here 2 and 1. Now we know what to do, right? First we'll draw a number line, marked O as origin, and we have taken here OA is 2 units. So we have taken OA, marked A here so that OA is 2 units. And then we know that AB is 1 unit. So we know that AB is perpendicular at A. So we have drawn a perpendicular line and we have marked B so that AB is 1. AB is 1. And we joined O and B so that OB is root 5. And with the help of compass, we have measured OB and marked it on the number line. So what have you observed in the decimal expressions of rational numbers? Here, in one case, we have got what? A non-terminating, repeating answer. And in the next one, we got a terminating answer. So remember students, keep this in mind always. The decimal expressions of rational numbers either are terminating, or the second case, non-terminating, repeating, or we say as non-terminating, recurring. So decimal expression of rational numbers either are, first case, terminating, as in the case of 1 by 5, we got the answer as 0.2, which is terminating. And the second case is what? Non-terminating, recurring, or repeating. So which is that case? For 10 by 3, we got 3.33333. So 3.3 bar, which is non-terminating and recurring. So whenever in a number line you come across any number like 6.15637, which is terminating, or 5.121212, and it keeps on going like that. And here it is 5.12 bar. The bar is on top of 1, 2. And here you can say that it is a rational number. So that, for example, whenever you come across a number like 6.13725, or a number like 4.121212, here it is 4.12 bar. So whenever in a number line you come across any number like this one or this one, which is terminating or non-terminating, recurring, you can say that it is a rational number. Clear? And now we will move on to the next topic, that is decimal expressions of irrational numbers. We know that we have seen the decimal expressions of rational numbers. Now we move on to the decimal expressions of irrational numbers. You all know that root 2 is a irrational number. So first we'll find the decimal expression of root 2 using what so root 2 is 1.4142. It goes on. So what did you find here? Is it terminating? No. Is it non-terminating? Yes, it is non-terminating, right? But is it non-terminating and repeating? No, it is not non-terminating and repeating. Here it is non-terminating, but it is not repeating. So how will we define a decimal expression of irrational numbers? It is always non-terminating and non-recurring. So the decimal expressions of irrational numbers are always non-terminating, non-recurring or non-repeating. For example, you know root 2, right? 1.4142 extra. And for example, we can give 0.10, 100, 1000, 10000, extra. Another example is what? 0.30300300, extra. So these are the examples of the decimal expressions of irrational numbers. They are always non-terminating and non-recurring. So the decimal expressions of rational numbers are, first one, it may be terminating, or the second case it may be non-terminating and recurring. And in the case of irrational numbers, it is always non-terminating and non-recurring. Now let's look into how to plot real numbers on a number line. For example, we'll take this number 2.665. Okay, and you all know that it lies between two integers, right? 2.665 lies between 2 and 3. So what is there between 2 and 3? 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and 3. So again look into this number 2.665. So it comes in which interval here? It comes in this interval, right? Between 2.6 and 2.7 it comes, right? So again we'll plot this interval into another number line. Okay. So this is 2.6 and this is 2.7. So what comes in between? 2.61, 2.62, 2.63, 2.62, 63, 64, 65, 66, 67, 68, 69, 69, 7. So 1, 2, 3, 4, 5, 6. So this is 2.66 and this is 2.67. So again look into this number. It comes under this interval, right? First one was this interval and now it comes under this interval, right? Again we'll plot this into another number line. .66 and 2.67. So what is this? 2.661, 2.662, 2.663, 2.66, 4, 2.665 and 2.665. You got 2.665. So this one. So this is the way how we plot the real numbers on a number line. And this process is called the process of successive magnification. So first we know that it comes 2.665 comes between 2 and 3. So we have plotted the 10 numbers between 2 and 3. That is what? Which one? 2.1, 2.2, 2.3, 2.4, 2.5, 2.6 and till 2.9. And now further if we look, we found that 2.665 lies in this interval, that is between 2.6 and 2.7, right? So again we magnified this into this number line. Okay, what comes under this now? That comes here. So between the interval 2.6 and between the interval 2.7, what all numbers will come? 2.61, 2.62, 2.63, 2.64, 2.65 and 2.66, right? And goes on. And again we look into the number, we know that this number lies into this interval between 2.66 and 2.67. And again we magnified this, and this interval now we plotted again onto this number line, right? And what comes between 2.66 and 2.67? It is 2.61, 2.661, 2.662, 2.663, 2.664 and 2.665, which is the required number. So we will plot the real numbers like this. Clear? Okay. Now we'll learn how to plot root x for any positive real number x on a number line. Okay. For this, first we will draw AB, which is equal to x. Take any length x. Mark AB as x. We need to find root x. So mark AB as x. This is x. A, B. This is x. Okay, we marked AB as x. Now mark a point C, which is 1 unit more than AB. I marked a point C here so that this BC is 1 unit. So now AB is x unit and BC is 1 unit, right? Now what we'll do? We need to find the midpoint of AC. We need to find the midpoint of AC. So for that, I'll draw the perpendicular bisector so that I can find the midpoint. See, this is the midpoint. See, this is a midpoint of AC. I marked it as O. Now we can erase these marks, okay? Now we can erase these marks. We just need to find the midpoint of AC, which is O now. So, with O as center and OA as radius, we'll draw a semicircle. Okay, we have drawn a semicircle. Now what I need to do? I'll draw a perpendicular line through B so that it touches the semicircle. So for this, I need the protractor. marked it as D. Actually, this is root x. So, this is root x, and now we have root x value, and with that we can mark with the take the measurement of root x and mark it on the number line. So now we will prove this. Okay, prove BD is root x with the help of what? Pythagoras theorem. Okay, how we'll do that? You know, see, this is a right angle triangle, right? OBD is a right angle triangle. OBD is a right angled triangle, and this is a what? This is a hypotenuse. So according to the Pythagoras theorem, what we have? OD square is OB square plus BD square. We need to find BD and prove that BD is root x, right? Now we'll prove it. So, you know what is OC and OA and OD? These all are radius of the semicircle, right? So, OA equal to OC equal to OD is what? Radius of the semicircle. What is the radius of the semicircle? Here AB. Here diameter is what? AB. AB is x and BC is 1. So diameter is x plus 1. So radius is x plus 1 by 2. So this is the radius. Okay. So now here OD is what? X plus 1 by 2. We have this one, and now we need to find what? OB. What is OB? See, look carefully into this picture. See, OB. We have OC, right? We have OC. OC is what? The radius. OC is x plus 1 by 2. From OC, if we minus BC, we'll get OB, right? So what is OB? OB is OC minus BC, which is equal to OC is what? X plus 1 by 2 minus BC is 1. So how we'll do this? X plus 1 by 2 minus 2 by 2, which is x plus 1 minus 2. How much it will come? Minus 1 by 2. So here this one also we got. So let's put all these things into the equation. OD square. Where is OD square? Here it is what? X minus 1 by 2. So what is OD square? OD square is x plus 1 by 2 the whole square is equal to OB square is what? X minus 1 by 2. X minus 1 by 2 the whole square plus BD square. We need to find the BD, right? BD square. So what is this? OD square is equal to OB square plus BD square. OD square is the hypotenuse is what? X plus 1 by 2. We have seen it here, right? X plus 1 by 2. So here x plus 1 by 2 the whole square. And next one, OB square. OB square is what? This one. This one is x minus 1 by 2. X minus 1 by 2 the whole square plus BD square. Now we need to find the BD square. BD square is x plus 1 by 2 the whole square. We'll take this one into this side. So this is plus, no? This whole is plus. So when it comes to the other side, it becomes minus. Minus x minus 1 by 2 the whole square. So how we'll solve this? So it is a square minus b square. So what is a square minus b square? I'll write here. What is a square minus b square? Is a plus b into a minus b. So a square minus b square. So a plus b. So x plus 1 by 2 plus b plus x minus 1 by 2. And then into a minus b. X plus 1 by 2 minus b. So we'll take minus of x minus 1 by 2. So these all are having the same denominator, right? We'll put 2 upon x plus 1 plus x minus 1. Okay, so now we have the first term. We'll take how many x? 2x, and this cancels, right? So we have 2x by 2 into what? X plus 1. We'll open the bracket, so it is minus x minus and minus become plus 1 by 2. So 2x by 2, and then what? These two got cancelled, and we have 2 by 2. So this get cancelled, this get cancelled. So we'll get x. So now what? BD square is x. So what is BD? BD will be root x. So I'll write it here. I don't have space. So BD square is x. So what is BD? BD is root x. So here we have proved BD as root x. So for any positive integer, for any positive real number x, can we plot for any positive real number x? How can we plot root x on a number line? We use a similar way to plot the root x on a number line. First we'll take the x as AB, then we add 1 unit to it and make it BC, and now we'll take the AC. AC will be the diameter, and we'll find the midpoint of AC and mark it as O. With OA as a radius, draw an arc, draw a semicircle. Then from B, draw a perpendicular line which intersect the semicircle in D, and BD will be the root x. We'll do one more example, that is root 3.5 on a number line. How will we plot root 3.5 on a number line? So what we have to do? We have to mark 3.5 units first. Three 3.5. Okay, so this will be my A, B. Here it is what? 3.5. Okay, and from B I'll mark another point C, which is 1 unit. So here I'll mark another point C, which is 1 unit. So now my new diameter is what? AC. I need to find the midpoint of AZ. I'll take more than half of the radius, and So this will be my O. I'll erase these arcs. And now I'm having O. What will I do? With OA as a radius, okay, I'll draw an arc with OA as a radius, and now from the point B I'll draw a perpendicular and now it intersects the arc semicircle at point D, and now BD is what? BD is root 3.5. Now I'll extend this one. And now I'll take so this one, this is what? Root 3.5. I marked it as P. So now you understood, no? How to plot any root of any number on a number line. Now let us discuss the operations on real numbers. That is, if we add or subtract a rational number and with another irrational number, or a irrational number with another rational number, the answer will be, what is answer? The sum or the difference will always be irrational. So if we add or subtract a rational number and irrational number, the sum or difference will always be irrational. And also, if a rational number and another irrational number is multiplied or divided, we will get irrational number. But if we do any operations on two irrational numbers, that is, if it is sum, difference, product, or division, the answer can be anything, irrational or irrational. So keep those on your mind. Now let's see some identities on square roots. The first one is root of AB is equal to root of A into root of B. That is, root 15 is what? Root 5 into root 3. We can split this. Okay. So the second one is root of A by B is root A by root B. So for example, root of 6 by 7 is root 6 by root 7. The third one is root of A plus root B into root A minus root B. It is same as A plus B into A minus B. What is A plus B into A minus B? A square minus B square. You know A square. Root A square is A and root B square is B. So A minus B. And the similar one, the fourth one is also similar one. A plus B into A minus B. So A plus root B into A minus root B is what? A square minus B square. So A square minus B square is what? Root B the whole square is B. And the fifth one, root A plus root B into root C plus root D. So what is this? Root A C plus root A D plus root B C plus root B D. And the sixth one, root A plus root B the whole square. A plus B the whole square is what? A square plus 2AB plus B square. So A plus 2 root AB plus B. Here the last one is root a minus b the whole square is a square minus 2ab plus b square, right? A minus b the whole square. Same, a minus 2 root ab plus b. Now we'll solve some problems based on the square root identities. Okay, the first one is rationalize denominator of 1 by root 5. What is rationalize meaning? Rationalize meaning here we have to rationalize denominator. So denominator should be a rational number, right? So first one we have 1 by root 5. So what we will do? We will multiply both the denominator and numerator by root 5. So into root 5 by root 5. So here we will get 1 into root 5 is root 5. Root 5 into root 5, 5. Right? So this is the answer. So rationalizing denominator of 1 by root 5 will get root 5 by 5. So the next question is rationalize denominator of 1 by 2 plus root 3. How will we rationalize it? So we will multiply both the numerator and denominator by 2 minus root 3. So 1 by 2 plus root 3 into 2 minus root 3 into 2 minus root 3. What will we get? 2 minus root 3, and here what it is? A plus b into a minus b. What is a plus b into a minus b? A square minus b square. So a square is 2 square minus root 3 square. So 2 minus root 3 by 4 minus root 3 square is 3. So 2 minus root 3 by 1. So the answer is 2 minus root 3. So we will see one more example. Rationalize the denominator of 5 by root 3 minus root 5. What we'll do now? We have to multiply both the numerator and denominator by root 3 plus root 5. So 5 by root 3 minus root 5 into root 3 plus root 5, root 3 plus root 5. So 5 into root 3 plus root 5 by, what is a minus b into a plus b? A square minus b square. Root 3 square minus root 5 square. So what it is? 5 into root 3 plus root 5 by 3 minus 5. So what is 3 minus 5 is minus 2. 5 by minus 2 into root 3 plus root 5. So we'll take this negative sign to the numerator. So it will be minus 5 by 2 into root 3 plus root 5. Clear? We'll see one more example of the rationalizing the denominator. So here rationalize denominator of 1 by 7 plus 3 root 2. All these examples are from your NCERT textbook of class 9. Okay. So what we'll do, how to rationalize? Multiply numerator and denominator by 7 minus 3 root 2. So 1 by 7 plus 3 root 2 multiply by 7 minus 3 root 2. 7 minus 3 root 2. So numerator will be 7 minus 3 root 2. And here a plus b into a minus b, a square minus b square. 7 square minus 3 root 2 the whole square. So it will be 7 minus 3 root 2 by 7 square. 49 minus, what is 3 root 2 square? 3 square and root 2 square. 3 square is 9 and root 2 square is 2. So 7 minus 3 root 2 by 49 minus 18. So it will be 7 minus 3 root 2 by, what is 49 minus 18? It will be 31. So what is the answer? 7 minus 3 root 2 by 31. Now we'll move on to the next topic, that is laws of exponents for real number. So the first law is what? A raised to m into a raised to n is equal to a raised to m plus n. And the second one is what? A raised to m, the whole raised to n is equal to a raised to mn. And what is the third one? A raised to m divided by a raised to n is equal to, this all you have studied in the previous class, right? A raised to m minus n. And then the last one, a raised to m and b raised to m into b raised to m is equal to ab the whole raised to m, right? And also you know that a raised to 0 is equal to 1, and also 1 by a raised to n is equal to a raised to minus n, right? This all you have been studying in the previous class. Also keep in mind that a raised to m by n, okay, a raised to m by n, it is not a into m by n, okay, it's not that. A raised to m by n is equal to nth root of a raised to m, okay, this you have to keep in mind. A raised to m by n is equal to nth root of a raised to m.